So in this lecture, simply I'm going for mesh analysis by using voltage source here. So I will apply one mesh inside this loop here. Again, I will apply one more mesh inside this loop here. And this, I will make this loop current in a clockwise. I'm making this loop current in a clockwise here, in a clockwise. Then this loop current is, this mesh current is I1 and this mesh current is I2. So in mesh analysis, we should apply KVL. So we should apply KVL. And before going for KVL, we should also know the branch current. And here in this case, we are having two sources. So we are having two sources. So we are having two sources. So make any one source as reference here. Make any one source. Make any one source as a reference. As a reference. Make any one source as a reference. Okay. Then I will make V1 as a reference here. Then from the V1, a branch current will flow like this. A branch current will flow. From the V1, a branch current will flow. This is my branch current. So this is my branch current. Everyone know the branch current means a current which is flowing from plus to minus from a given voltage source. And here in this problem, we are having two sources here. One is V1 and one is V2. And my branch current is coming from V1, that is from plus. This branch current will move like this. And once the branch current is coming at this place here, the branch current will divide into two branches. So again, one branch current is moving like this. One branch current is moving like this. I'm not caring for voltage source V2 because I taken V1 as reference one. And again at this point here, this both will combine here. Again, the branch current is going for minus. In this manner, initially make the selection of the branch current and loop currents here. And I taken the loop current in a clockwise here, and branch current I taken from V1, that is from plus to minus. Okay, now we should apply some formulas here. Okay. So now we are going for some formulas here. This formula name will be the sign convention. The sign convention for resistive branch, for resistance here. We are having two formulas here. We are having two formulas here. So one formula will be, we can see here, for suppose we are having a resistance R1. Here the branch current, this is a branch current. This arrow mark which I am showing here is a branch current. So the branch current is moving in a clockwise here. Assume the branch current is moving in a clockwise here, whereas the loop current is also moving in a clockwise here. The loop current is also moving in a clockwise here. Then we have seen the branch current and my loop current are flowing in the same direction here. Whenever, so then you can write one sentence here. Whenever branch current and loop or mesh, anyone is same, okay? So whenever branch current and loop current is flowing in the same direction here, is flowing in the same direction, then the voltage across resistance will be, the voltage across resistance is voltage drop, and sign convention is given by given by positive sign. Positive sign. So whenever branch current and loop current is flowing in the same direction here, then the voltage across the resistance will be the voltage drop, and sign convention is given by negative sign. Sign convention is given by negative sign. In some books, they will go for positive sign here. There is no need to worry about this here. Okay. At last, every answer will be same. So I taken in a negative side. That is, then I can say that the voltage drop across R, the voltage drop across R is given as minus I into R. That is a sign convention. So whenever the branch current and loop current is flowing in the same direction here, then the voltage across resistance will be the voltage drop, and sign convention is given by negative sign, and VR is given as minus I into R. So in this manner, in a similar manner, we can go for sign convention for one more, but initially I want to make sure what is the branch current. Some people are having some problem here. What is the branch current? This arrow mark, this is called branch current. So this is a branch current, and this one is a loop current. This one, you can see this one. This one is a loop current. So you can say this is a loop current. Loop or mesh, anyone. So you can identify very easily whenever branch current and loop current is flowing in the same direction here, then I can say they are negative sign will come, voltage drop. In a similar manner, we are going for one more answer, but here whenever branch current is loop current is flowing in opposite direction, I will explain you, is flowing in opposite direction, then the voltage across resistance will be rise, and sign convention will be positive sign will come. Then I can say VR will be only I into R. Only I into R. In this manner, we are having some sign conventions here for two, and you can see here the branch current is coming in this manner, whereas loop current is coming in opposite manner. You can check here. The branch is coming in this manner and loop is coming in opposite. So whenever branch and loop are flowing in the same in an opposite direction here, then the sign convention is given by positive sign. Okay. In a similar manner, we are having sign convention for. So now we are going for sign convention for. Now we are going for sign convention for voltage source. So we are having two different cases. If you can learn this one, everything is simple, because if you know the mesh analysis very well, the theorems will be very, very simple. Now sign convention for voltage source, then very simple. Whenever voltage source will come here, only check the loop currents here. Only check the loop current. No need to go for checking branch currents here. But whenever resistance will come here, check for branch and also loop. But whereas whenever voltage source will come here, check only the loop here. Then here for suppose my loop current is moving in anti-clockwise in case number one, then I can say you can check here. The loop current is coming from plus to minus for a given voltage source. Don't verify the branch current, only verify the loop. You can check here. The loop current is crossing from plus to minus. Is crossing from plus to minus. Then you can write one sentence here. Whenever loop current flowing from positive to negative in a voltage source, then the sign convention will be, then the sign convention is minus V, negative sign, simply minus V. So whenever loop current flowing from positive to negative in a voltage source, then sign convention will be minus V. Only these are only sign conventions, Amma. So then we are going for one more, that is case number 2. So now coming for second case. Now you can check here in the second case, the loop current is coming from negative to positive. The loop current is coming from negative to positive. Then we can say that whenever loop current whenever loop current flowing from negative to positive, then sign convention will be, then the sign convention is positive V. So plus V. Simple. Only we are having 4 formulas here. If you can learn very well these 4 formulas here, so mesh analysis will be very simple. Then theorems are very simple. So once again I will revise this. Whenever loop current is coming from plus to minus V. Whenever loop current is coming from minus to plus V. Now we are going for again problem solving. So now we are applying KVL from the 4 formulas here, and we are finding the answer here. So very simple. Initial apply KVL for loop 1. Initial apply KVL for loop 1 or mesh 1, anyone, no problem. Then you can we can check here. So whenever voltage source will come, only check loop current. But whenever resistance will come here, check branch and loop both. So here in this example, the loop current is coming from minus to plus. We can see the loop current is coming from minus to plus. So whenever loop current is coming from minus to plus, then I can say plus V, minus to plus V. So plus 10. That is a sign convention here. Then coming for resistive branch. So for resistance R1, that is 2 ohms here, the branch current is moving in this way, and my loop current is also moving in the same direction here. Whenever branch and loop are moving in the same direction here, then I can say minus I1, because which current is flowing here? I1. So I1 into R1 means 2I1. So 2I1 minus 2I1. Then coming for one more resistance here in this loop here, coming for R2. Loop means this is one loop here. Coming for R2. Now here in this branch here, I1 minus I2 current will flows. Okay, but whereas in this branch here, I1 will flow, in this branch I2 will flow. But whereas in this branch, I1 minus I2 will flow. Then again we can identify the loop current and my branch current is moving in the same direction here. Whenever it is moving in the same direction here, then I can say minus I1 minus I2, minus I1 minus I2 into R, that is 5 ohm, should be 0. Simple KVL, simple equation here. Okay, then minus 2I1 and minus 5I1, minus 7I1, minus 7I1, minus 7I1, and plus 5I2 is equal to minus 10. Is equal to minus 10. This is equation number 1. This is equation number 1. Okay, that is equation number 1. Now coming for apply KVL for loop 2. Apply KVL for loop 2. Okay, apply KVL for loop 2. Then again we know the loop current is coming from plus to minus for a given voltage source. Then I can say whenever plus to minus, minus 5. And again, we can see for a resistance R3, the branch current and my loop current is flowing in the same direction here. Then minus, so then I can say minus I2 into R3. What is R3? That is 10. So I can say minus 10 I2. Okay, minus 10 I2. So then one more, resistance R2. We can see the branch current is moving like this, whereas the loop current is opposing. The loop current is opposing here. Whenever branch current and my loop current is opposing here, then plus I into R. So then I can say plus I1 minus I2. Which current is flowing here? I1 minus I2. I1 minus I2 into 5 should be 0. Okay. Then how much? 5 I1 minus 15 I2 is equal to plus 5. This is equation number 2. Solving two equations, we can find equation I1 I2. So we can say solving these two equations, solving this equation 1 and equation 2, we can find I1 I2. Okay, so solving these two equations, I1 by using calculus, we can easily solve. Go to equations and find 1.5625 ampere, that is I1. Then I2 will be 0.1875 ampere. In this manner, we can find I1, I2. So now I hope you people understand this mesh analysis here. Initial very simple, apply loop in clockwise here and make any one source as a reference one here. Then from one source here, the branch current is moving like this. Then apply KVL for loop 1 and apply KVL for loop 2. Then for each and every, for suppose whenever voltage source will come, only verify the loop current, and whenever resistance will come here, verify the branch and loop both. Okay. So thank you. I hope you understand. Now I will verify by using circuits lab here. So now I'm doing by using circuitslab.com here, and I will verify my answer. And I'm placing one ammeter in this branch and in here, and from here I can find I1, and from here I can find I2. So we can verify the answers. Okay. So now we are going to find so once I verified here, now you can check. Now you can check here. What is I1? Current passing through I1 is 1.56 ampere, same as it is. And current passing through I2 will be 187.5 milliampere, same as it is. We got 0.1875. So 0.1875 or 187.5 milliampere is okay. Now our theoretical and also practical is verified. So I have done mesh analysis by using practical, by using circuits lab. I verified this answer. Okay, so thank you for watching this video, and if you like, you can share with your friends. In future I will do much more videos for you people. Okay, so thank you for watching the mesh analysis. Okay,